why scientists choose 1/2 as electron spin. Why 1/2? What is the physical significance of this half integral spin? I had already uploaded 2 videos on my YouTube channel. See, this is my YouTube channel, physics and inverse. There are 2 videos already over this. The first video was what is a spin. When you scroll in the video section of my channel, you can see what is a spin, what is electron spin. There I had explained Dirac-Spinor equation and these things. And then there's another video. Why does electron have a spin 1/2? What is the physical significance? There I had demonstrated with a very simple example. Here we understand that what is the value of half integral spin. Means, as we know, everything goes into its initial state after 1 revolution. Means after revolving by 360 degrees, it goes into its initial state. But electron goes into its initial quantum state after 2 revolutions. Why it happens? What is the physical significance? And it has been demonstrated by very simple example. Let's see, today I will analyze these things in detail here in this my YouTube live. I invite you to comment, to ask your questions, and to suggest my errors also. I'll be glad about your comments and about your suggestions. Okay, see.
One person has joined. Who is this? Yeah, Quantum Mathematics 777, the same person.
Yes. Here, see, the story begins.
Good evening, sir. Another comment from that same channel.
Okay, don't worry. Yes, let me check the comments who are commenting. How can I check
It's
this?
a similar channel who have joined us in the live yesterday, last Sunday.
Yeah. Here is a problem.
They're telling you good evening. Explain the topic one more time.
Yes. Yes, good evening everybody. Now see, today's topic is here. What is electron spin? Simply explain. You have studied in books or in the quantum physics that what is electron spin, the calculation from the Dirac-Spinor equation and the lengthy calculation. I'm going to skip all these things and I'm telling you what is the physical intuition of electron spin. How we can teach a child what is electron spin. And the second thing is why half integral value for electron spin. Why they have taken 1/2 as the electron spin, the value of electron spin. What is its physical significance? As I discussed earlier in this live, and I'm discussing again that I had already uploaded 2 videos on my YouTube channel over these 2 topics. And today's live will be the resultant of those 2 videos. And whatever question you have, you can ask me, you can suggest me my errors. These are my works. I'm telling you that these are not the proven works total, not complete proven works. I have studied from book and then these are my research work. I'm trying to please you, I'm trying to admire you with my works in a very simple way. The main problem of quantum physics is that it's very, very uncertain. We have to work to reduce its uncertainty and bring quite certainty into its explanation. There are a lot of mathematical calculation, but there are very less physical significance of those calculations in today's quantum physics analysis. My approach is to reduce the uncertainty and extracting physical significance more from that mathematical calculation. Okay, come here. The story started from Schrödinger equation. Schrödinger, by the help of de Broglie and other board scientists, they found that like photon, electron also behaves as a wave. And this was very striking. What kind of wave it is? Either transverse wave like light or not longitudinal wave like sound. it was a very different type of wave, matter waves. And Schrödinger has,
6 people have joined.
okay, see here. And Schrödinger was very successful in explaining what kind of wave was an electron. Let's start from Schrödinger equation. Schrödinger used this concept. This is Hamiltonian of the matter wave function, then total energy matter wave function. These are equal. This is a Schrödinger equation for an electron inside an atom. This is matter wave function. This function, it's a complex wave, means it has explained in terms of complex number, a real part and an imaginary part, and these things are making quantum physics quite uncertain. See here. After solving this, Schrödinger used the total energy of an electron in very classical way. Schrödinger started in a classical way. It was kinetic energy of an electron and potential energy of the same electron. For kinetic energy, he used 1 by 2 mv squared plus potential energy. He used the potential disturbance there, either gravitational, electrostatic, whatever you feel. No particular value, but a V representing the potential energy of electron inside an atom. And he used this term to represent the total energy this. And after utilizing this in the equation, this equation has a form like this, see. In one dimension, I'm explaining it in 1D, one dimension. This plus potential energy with the matter wave function, and after, is it visible in the light?
Yeah, it's visible. V psi is visible.
And after that, is it visible?
Yeah, your hand wheel is reaching.
I means d by dt, this. This will be the equation. For 1D, we don't need to write this. Let me to write this. This will be the equation for 1 dimension. And in 3 dimension, it will be like this. This. And or simply, after differentiating in all the 3 axes, we can write simply like this. This is the easier notation. We can use this, but to make it simple, understanding a simple way, I'm using this. Rest everything was as usual. Is this visible?
I don't think so. Wait.
Okay.
Yes, I have tilted it. Wait. Yes, now it's here. And now I'm taking it back.
This is 1-dimensional equation for an electron in an atom, and this is 3-dimensional. You can understand analysis over this for ease, and that will be applicable over this easily.
And write that part when you're done with it. Wipe it. Because when I take the camera, it becomes invisible. Yeah, now it's
This is not the exact 3D equation, because when 3-dimensional equation, we have to use a spherical polar coordinates, and it will become very lengthy and very tough to analyze. But to make you understand, from 1D to 3D, it will look like as this. So no need of this, just we concentrate over this. This is one-dimensional equation for an electron in an atom by Schrödinger. It has explained many things, the existence of electron inside an atom, especially in the orbit, how its existence in the orbit, how its means rotation in the orbit, revolution in the orbit, angular momentum, stationary orbits, and jumping from inner orbit to outer orbit, outer orbit to inner orbit. All these things have been explained by the help of Schrödinger equation, 1D and 3D. But there is no room for a spin in this equation, neither in this. What is electron spin? It's not clear. Means if you study a lot about Schrödinger equation completely, you can't find what is electron spin. For a spin, we have to move forward to it. And here's the story start for the Dirac equation. Let's see. What is the Dirac equation? See, for Schrödinger, for this total energy, Schrödinger used this classical analysis. Here, Dirac thought that when an electron is moving with a high speed, means relativistic speed, Einstein's equations were more active than the Newton's equation. And Dirac thought that why should not we use relativistic total energy instead of classical total energy? And that's the beginning of his spin here. See. According to Dirac, for this, Dirac started the total energy as this. Or remove this. E squared is equals to mc square, m square c power 4 plus p square c square. Remember this. This is Dirac. Means Dirac used this total energy, total relativistic energy, because when an electron is moving at high speed, then classical equations aren't sufficient to explain its total energy. And Dirac used relativistic total energy. There, this is the rest mass energy of a particle, and this is momentum and the speed of light. This is the total energy. And Dirac used this in this equation. And you know, when Dirac used this value here, then this equation, which was earlier in the form of Schrödinger equation, changed its shape completely, and it looks like something insoluble equation like this. See. Let me to write the equation because it's lengthier. I don't remember. I'm seeing from my copy where I had my research works. See, it looks very different. Very different than that.
Someone is sending you hi up there, W6G.
Yes, hi and good evening. Welcome to my live. I'm telling you, see. After putting this value and solving for this, we get an equation like this.
This is not a neat chapter. Someone is asking, is it the neat chapter? No, it's not a neat chapter.
It's not a neat chapter. It's electron spin. in a detailed way, the Dirac analysis, Dirac equation, why electron has half integral spin. So for neat analysis, you can say which topic do you want to know. I will explain that in next live, or whenever you want, I will explain it. Which topic do you want?
It hasn't came the answer. Speak up while writing the question.
Yeah, I'm speaking, don't worry. See. Now, after checking this equation, you thought that
Yeah, the student, it's maybe someone is student, they are saying you to make the video on moving charges and magnetism.
on moving charges and magnetism, do you want the whole chapter or you want some highlighted topics? Tell me.
The channel's name is Akshay W6G. Okay, we'll make it on the own channel.
I'll make it. If you want, then in tomorrow live, arrive at 10 o'clock at night, I will explain that chapter, okay? In
Yeah.
tomorrow's live. Tomorrow at 10 o'clock. Join me for that moving charges and magnetism.
Analyze it now.
See, those who were familiar with the Schrödinger equation, they find this equation very different and quite less similar to the Schrödinger equation. Here is a twist. After solving this equation, in the traditional method, they never get a solution because there are under root and it was very complex.
This student is asking, in which college do you actually teach, sir? We don't teach in any college.
These are my own research works. Do you know, these are my own research work after studying. And I'm uploading this on YouTube and Facebook, not in any college. Whatever problem you have, you can ask me and tell me about a topic. I will go in live. I will explain videos over it. And any problem for JEE NEET, you can ask with me. But right now, I'm explaining electron spin.
Why electron has half a spin?
Yes. See, these two topics.
And this topic is not in any book.
And after studying book, I have done my own research work and I'm explaining that here. See.
He said thank you and bye.
Okay. So, to solve this equation, we can't solve this equation in a traditional way by solving an equation. We have to assume something. And for that assumption, there are three constants. I have four constants: alpha x, alpha y, alpha z, beta. These are four constants. And these constants were the game changer in the Dirac equation, different than Schrödinger equation. Means they open a new door for quantum mechanics, where quantum mechanics was earlier more uncertain. After getting this constant in this equation, it becomes more and more uncertain, and that's the beauty of quantum mechanics. See here. Now, I'm not going deeply to solve it step by step. I'm giving you some values. Let me raise this.
Don't worry yourself too much. The camera is moving.
Okay. So, for alpha x, we need a value like this. See, for alpha x, we need a value like this.
Speak up while writing.
Wait, this. This is the value of alpha x. This is a matrix, 4 into 4 matrix, where only 4 components are 1 and rest are 0. Similarly, alpha y. This will be the value of alpha y. Means it was guess. They guess it, how will you solve the equation? To solve this equation, they have to put some values here. And those values are matrices. And similarly, alpha z will be this. Let me write this. Alpha z and beta were also matrices of 4 into 4.
There's a comment, are these constants similar in any possible way to polyspin matrices?
Yeah, these are polyspin matrices. When we contract this and this and this, it will generate in a 2 into 2 matrices, and those are polyspin matrices.
It is the extended version of polyspin matrices, and they are Dirac matrices.
This is the base. From here you understand everything. You don't have to memorize what is electron spin and why they need such a very different abstract way to explain it.
So, second question, Jordan blocks. Is it Jordan blocks?
Jordan blocks, I'm unfamiliar with the Jordan blocks. I'm going with the traditional equation of Dirac to explain the spin.
It's the channel quantum mathematics 777.
Yes, thanks for your comment. This.
They have joined us at the last Sunday's live too when I was explaining the Jordan block matrices. Let me search it on your Google. Is it the same thing?
No need to search. These are my own works. Don't worry.
Okay, then tell them that you're not trying.
See, these are alpha x, alpha y, alpha z, and beta. These are the matrices. And when we contract it, it will convert into polyspin matrices like this. See, how can we write it this? This 4 becomes 0. And what it will become? 0 minus 1. That will be minus 1. And this will be again minus 1. And this will be polyspin matrices. Similarly, you can do this. Here, there will be some physical analysis there, and that's why there will be some changes in the sign. That's a later topic. See how a spin evolved from this. After putting these values in there, we get solution of the Dirac equation in a very different way. It was not the traditional solution of Schrödinger, where there was just one matter wave, which has one amplitude and one kx minus omega t as I, which was way different than this. And after getting through this, sorry, for the free particle, B is equals to 0. Just only time component here. This was a Schrödinger equation, a Schrödinger matter wave. One amplitude, this is time independent value, and it has time here. It depended on time. This is the phase and this is the amplitude of the matter complex wave. After using these constants in Dirac equation, we don't get one single and one unidimensional value. We get the solution of Dirac wave function as this C. Let me delete this. And it was 4-dimensional. That's very surprising. It was 4-dimensional like this. It was 4-dimensional, like this. It's the function of x and t e by h cross c. This is the total energy, total relativistic energy here by h cross. This was the value. But here, remember one thing. In Schrödinger equation, this value has one single value and this amplitude is just one single wave function. But here, it would be defined in this way. It has 4 components, like this. That's the difference in Schrödinger equation and Dirac equation. Schrödinger matter wave function and Dirac matter wave function. In Schrödinger matter wave function, we have one single amplitude, but in Dirac matter wave function, after solving equation with this constant, we have the time part, the phase part was already same, but the amplitude part has 4 components. And this was very surprising. How something is moving in one direction suddenly changes into 4 different ways. And the most surprising was these 4 components all lie along x-axis, but they are orthogonal to each other. Means very surprising. They all lie along x-axis, but orthogonal to each other. Means they are independent to each other, not interfering. And completely independent means they are normal to each other. How is it possible?
It's not a Jordan-Bloch matrix, because in Jordan-Bloch matrix, the lambda eigenvalue has constant.
Okay, that's a different part.
Yeah.
Let me explain
It's
this.
not that much.
This.
It's Dirac matrix.
In Schrödinger equation, we have, this is Dirac matter wave function. And for Schrödinger matter wave function, we have just this eigenfunction, which is time independent along x-axis if I am explaining one-dimensional motion.
I don't think that would be visible. Why am I writing it there?
It's not visible there?
No, it will not be visible. Wipe the matrices part if you don't need it.
See.
Yeah, it's visible.
See. This is Schrödinger matter wave function and this is Dirac matter wave function. Understood? Notice the differences. Here the total energy is classical total energy, kinetic energy plus potential energy. Here this is relativistic total energy, that Einstein's equation, E equals to under root P square C square plus M square C power 4, where P is the momentum of the particle. Notice the difference. Here the amplitude was just one-dimensional. Here amplitude has 4 components. All the 4 are one-dimensional, but they are completely orthogonal. How is it possible when they all are moving in one dimension along x-axis, but they are not interfering to each other? They are orthogonal to each other. How is it possible? According to Dirac, these four components are along x-axis, and there is no explanation in quantum mechanics that how something is moving in one direction, splits in four, and all the four are independent to each other. Orthogonal, completely, no inter. If they are along same line, they will interfere each other. They have taken it as usual due to some mathematics, but my works are here. What is my work? I thought that one of these are maser, which is the major component of amplitude that is along the axis where we are analyzing where the electron is moving, and rest three are orthogonal to each other. And within this Dirac equation, after solving Dirac equation, they noticed that two of them are zero. Two of them are zero. Means not all the four components exist together. They can't exist together. If they exist, it means that 2 for electron and 2 for positron. From here, the antiparticle of electron originates. So, making it simpler, we are going to put two values as 0. Understood? Any two value as 0. Because these two components are for electron, then these two components are for positron. Means, again a surprising thing, at extremely high speed, the same wave contains two particles. In classical range, the wave which was used to analyze one single particle, now it has two particles in its packet at high velocity. In future, at extremely high velocity, greater than the speed of light, maybe it has many particles inside it. That will be the future research works. Right now, at Dirac relativistic speed, the single wave in Schrödinger equation now has two particles inside it. And the four components, as a combined form, had just 2 for electron and 2 for positron. So if I'm explaining this matter wave function for electron, I'm keeping any two exist and rest 2 as 0. Now here, my works are, one is major and other is minor. Means one is the major wave which is propagating along the direction of electron. Means along the direction of wave, matter wave. And another amplitude is minor. This is quite smaller. If I take this measure, then this will be quite smaller. This measure, then this will be quite smaller. Here is a twist. Nobody has explained what is the shape of a matter wave, complex matter wave. The wave which is in complex function representing an electron or other particles like proton or this or quarks, nobody has shown its shape and size. I'm working here. I thought that the major component, if this component of amplitude is major, then this is like longitudinal wave pattern. And the minor...
Someone is asking, there's a dot. Okay, ask.
What is dot? Tell me.
Art of writing for the channel's name, and they are asking some dot.
What is your dots? Tell me.
They are just commenting. The comment hasn't reached yet.
First of all, listen, this is my works. I'm explaining my works. So you may have some deflection from the proven works in book. I'm explaining my works. So keep in mind. Now tell me, what's your comment?
The comment haven't arrived. When it arrives, when I will tell you. Okay. First explain that how the electrons are spin. Yeah, I'm reaching out there.
I'm reaching out there. See, actually this was the story. Building up the concept, what is electron spin? From Schrödinger equation, we jump to the Dirac equation. And in the solution of Dirac equation, you notice a spin. I'm just going there. You'll notice that. Let me raise this. There is no room for electron spin in Schrödinger equation. Thanks for the watching and taking interest in this slide.
We have one viewer and They are continuing what you take this part. Right now we have three and four.
See, this will be the solution of Dirac. Notice, after solving Dirac equation with the matrix alpha x, alpha y, alpha z and beta, we got something like this.
Another question from the same channel.
Yes, tell me.
What is the rotation of the spinning the electrons?
Yes. Yeah, I will explain it. Means have some patience in this slide, and after 10 minutes I will demonstrate you what will be the half integral value of electron spin. Why? Just
there's another comment again, so please explain in concise way, not the whole story.
Okay, I'm going there. Just if you have waited for that much, wait for 5 or 10 minutes. Sorry for delay, but because this is very interesting turn from Schrödinger equation to Dirac equation, and in there you feel that what is the root of electron spin. This is solution of Schrödinger equation. We get a matter wave representing an electron, this Schrödinger matter wave function. This is Dirac. Now, in Dirac analysis, they thought that it contains two particles, electron and its antiparticle, positron. See here, for electron, let any two as existing and rest two are zero.
There's again question from the
yes,
same channel.
Just in 5 minutes.
They are asking particles are rotating or not, in which state? What is plutonium, sir?
Just wait for 5 minutes. Let me go through this. What is a spin? Then you know. Then you understand everything well. See there. This is for electron, and this is for positron.
They are asking what is plutonium.
Plutonium is an element. It has no relation with here electron spin. I will explain plutonium in some other live or other video. Let's see this. Is it visible? I think no.
Yeah. The line is visible. After that, the thing is not visible.
This is not visible.
No.
Okay.
Please, sir, spinning is easy or difficult? First of all, tell me, it's not like a ball that you are thinking of it.
It's not like a spinning ball. Wait for 5 minutes. Everything will be clear,
Okay.
and you understand
They are
that.
saying that it's visible, rotate some camera.
Yeah, you will understand that from where a spin originates, what the root of it. Then you understand everything. See, for positron in Dirac Spinor equation, we call these amplitudes, four amplitude function as a spinor. Take it 0.
Blackish is coming. Okay, I'm trying to remove the blackish part. Okay, I think it's well now. Can see clearly.
Is it clear for you?
I think it's happening because of the slow network.
I think so. See there. For electron, remove any two amplitude, component of amplitude, and for positron, remove the other two. Now notice here, according to Dirac, they both are along the same axis and they are orthogonal. It's not possible.
It's still not clear, but it's clearly, visibly visible. Okay, let it.
What is my work? One is major. Suppose this is major and this is minor. Means this is bigger component of amplitude and this is smaller component. Means according to me, no one has explained what is the shape of matter wave function. How matter wave, they just tell that a lot of mathematical calculus. I'm trying to explain it. In these two, one is major, means one is bigger wave and there is a smaller wave, and they are orthogonal to each other. Means this is like longitudinal wave pattern and this is transverse to it. This is smaller. Remember here, if they switch their position, if something happens like this, they switch their position, that is a spin mathematically. According to Dirac matter wave function, if they switch their position from here to here, here to here, here to here, this is matter wave function. If it comes here, it comes here. That's mathematically a spin.
Someone is asking, have you watched FIFA World Cup? No, not yet.
Okay, I will watch at night, don't worry. It will start at 12:30. The switching position, the position of amplitude of a components of amplitudes, if they change their position, that is the spin, according to mathematics, quantum mathematics. But what is the physical intuition? Listen here. Come to this diagram. I'm showing you.
Someone has commented that this is a spam. No, it's not. See, the channel Quantum Mathematics 77, no, it's not a spam.
No, these are my works.
You will not find it in any book.
These are my works. After studying Dirac equation, what I think, I'm explaining that. Okay, see here. Nobody has explained what is the shape of matter wave. Matter wave is a complex function. They can explain something as longitudinal wave pattern. They can explain something as transverse wave pattern.
And you will understand this equation once you think it.
Initially I told you the quantum mechanics is very uncertain. The scientists rely mostly on mathematical equation. They accept some mathematical equation which has very less physical significance. Suppose that they tell you the electron is existing everywhere. If an electron is existing everywhere, then how it is inside an atom? At the same time and outside the atom at the same means my instinct is to reduce the uncertainty in quantum mechanics.
Show the diagram and analyze.
Now see, what is electron spin? I told you that switching this amplitude, the position is a spin. How it is related to electron, and what is the physical significance? Look there, make it down.
I'm making the camera down.
See here.
It's not a spammer. Someone has commented the quantum mathematics channel. It's something that you will not
See,
find on
in
channel.
quantum mechanics, there are a lot of things which are unexplained and undefined. Great scientists have just a speculation over it and math theory, what is say, qualitative analysis. Sometimes the quantitative analysis and qualitative analysis do not match.
Check.
Now see, my works, how I explain this. See, I told you one of the components as major component, which is the longitudinal wave pattern. See, this is it visible?
Yes.
See, this is the major component, and it's along the direction of propagation of matter wave. The minor one is orthogonal to it. According to me, it's orthogonal to it. And this minor one, which is a wave like this.
Oh, art of writing channel is a spam. I thought that you were telling me to block his video and that this is a spam. Sorry for getting you wrong. What I have told you that someone commented channel that this is a spam. No, they are telling that the channel art of writing was asking you earlier about these things.
Nobody.
They told me that this channel is spam.
Okay, don't worry. Let them.
We don't have the idea of that.
Anybody can, even spammers can ask some question, and I will try to explain it according to my knowledge. See, this is a smaller component of amplitude, and it's in transverse like wave. This is major component, and this is minor component. According to me, up to yet, whatever knowledge I have, electron is like this, a longer component which is in longitudinal wave pattern and a transverse like wave hovering over it. And what effect they generate, it's like a dancing a string. I'm showing you. See, I'm showing you. See, I'm showing you. It's See, like this. See this.
Yes, visible.
Is it visible? See, a major component of amplitude, which is longitudinal, but a minor is twisting it like a dancing. It's transverse like. This will be the design of electron, according to me. And why they have taken 1/2 as electron spin? See, according to the nature of electron with these equations, you have to take a spoon instead of this. The spoon is better. They noticed in the wave, matter wave function, that every other wave, every other particle, like a ball, after one rotation or one revolution, they reach to the initial state. But this equation for electron, it takes 2 rotations to reach the initial state. How is it possible? Let it here, don't worry. See, on board, this is bigger component and this is smaller component. One way I'm suggesting that the frequency of this longer wave, this longitudinal wave, frequency of this longitudinal wave is half the frequency of this transverse wave. In this way, you'll notice that the time it takes for one oscillation, till then, this is smaller transverse wave-like pattern oscillates twice. Notice, for this one oscillation, it goes to its initial state. It takes 2 oscillations within that time. Why they need this? See, after one oscillation, suppose if it goes for one oscillation and it also goes to one oscillation, then geometrically, in shape and size, they are identical. They are in their initial state. But due to the calculation of Dirac-Spinor calculation, there are something which is not in its initial state. It takes 2 rotation of this smaller component to get its initial state in the calculation. And from there, a story starts that it is 1/2. After one rotation, the mass, the charge, the shape of electron comes to its initial state. What doesn't come? That is the phase, this. The phase hasn't arrived in its initial stage after one oscillation of this and one oscillation this. The phase goes into its initial stage after one oscillation of this and 2 oscillation of this. And from here, the story arises that it is 1/2, means it completely secures its initial position after 2 rotation. Let me show you in a very simple way. See this. Is it visible?
Yes, it's visible.
Now,
Let me remove this.
aside this and see. For ease,
Take the plate more towards you. Here.
see, I'm putting a mark here. See. Suppose this is longer component, this is bigger component of amplitude, which is represented by longitudinal wave pattern, and this is a smaller or minor component of amplitude, which is represented by a smaller transverse component. Now see, they are intact to each other. See, notice, if after one rotation, they both are in the same position, but in electron matter wave, there is something that is not in initial position. It takes 2 revolutions of this smaller. And how I'm analyzing it, see. This. I told you the frequency of a smaller wave, transverse wave pattern, is twice than the frequency of this longer longitudinal wave pattern. See this. The time it takes for one revolution, one rotation, in that given time, it completes 2 rotations. See. Now see. Understood? Exactly same.
Do it once more.
See.
See. Yeah. But
See, when the bigger has completed half rotation, the smaller has finished one rotation.
there is some comment. Wait, let me check what is the comment.
And when bigger has finished one rotation, one full rotation, the smaller has finished two full rotation.
Okay, let me see.
Yes.
We got the comment from this group of rotational symmetries for electron is Z by 2Z groups of integer module 2. I'm thinking about that, the Lorentz group of symmetry for elementary particle like electron. I haven't. Have you read about the Lorentz group of symmetries?
That's a different thing. That's further than this. I'm telling you why half a spin. And for Lorentz symmetry, I will explain it in another video. See here. I'm just making a physical intuition for what will be 1 by 2. Have something comes in exact initial position after two rotation. So the bigger wave finishes one rotation and a smaller wave finishes two rotations within the same time. Why they need this? Because why? When the matter wave, this Dirac matter wave function goes for one rotation, it retains its mass, charge, shapes. But the phase of the shape, the phase of the quantum wave is still not retained. And it has retained again after second revolution. And that's why the term comes half integral spin, that it comes exactly in its position after two rotation, and two rotation of a smaller component, not the bigger component, because then it alters. That's the physical significance of 1 by 2. Now the Lorentz invariation or Lorentz spin analysis, these are from relativistic approach. I will go in another video over this. And that other thing, spin state, these things are
Implemented, that might be absolutely wrong. No.
no,
The
it's
research things are done like this.
it's not wrong. It's further than this. Here the
No. This channel.
see
this
this
channel, the quantum mathematics 777.
see, neither you are right, maybe I will be wrong too,
Yeah.
because this is research. We think we deliver our works, not always it will be right, not always it will be wrong. It has some, and in quantum mechanics and deep study, nobody has reached to the research exactly correct at once. There are some percentage. First time you secure 20% of accuracy, then 30%. Till then, dimension expanded, and we have a broad vision. So this deep research never is to final accuracy at once.
And any concept can apply in this
Yes,
research thing.
whatever you can think,
We
you
can
try
think.
to figure it out. And my main goal is to reduce uncertainty in quantum mechanics. And this is also a part. People say half integral spin. What is half? How will you teach a student what is half integral spin? Why something comes in its exact same position after two rotation, not one? Physically, it comes in initial state after one rotation. So my main motive is to reduce this uncertainty. And this was one of that. Half integral spin. How people relate, what is half integral spin? And from this, I noticed that this electron, relativistic electron, is not a spinning ball. It's a dancing string. Like something you say that dancing string means, you notice that reptiles means
Snake.
twisting its neck, not a snake. A snake has a fixed pattern. It has a fixed pattern. It will be very different. Sometimes oscillation will be different, because why? After every two rotation, it goes in its same position. So in between that, you notice that they both have not symmetry to each other. Bigger longitudinal wave pattern and a small transverse wave pattern have not symmetry in between, but at the end they meet at the same point. So it's like dancing a string. And now I'm starting to believe in a string theory. Earlier I was also very not satisfied with the string theory, but now I'm quite believing into a string theory. The string theory might be the most successful theory of modern quantum mechanics. And main thing, we have to reduce uncertainty in quantum mechanics. Mathematics is not physics. Too much mathematics, it has physical significance over it. And that's 1 by 2. And for detail, next Lorentz transformation, I will come with a new video. There I explain that how a moving wave, a matter wave, comes with a mass. As I explained that maybe I show you design, the design is representing an electron. So it must has mass. From where it get mass, how it get mass. For that I use my own work. Maybe it will be wrong, it will be right, but I'm thinking of it, and that will be my, how this wave, see.
We should fix a date for relativity and quantum.
How this wave, this moving wave, matter complex wave.
They are smiling. I knew the string word will come here. This is
comes, how it gives you mass. It, and what is its resemblance to the electron field? Because electron exists in an electron field. In any next video, it takes more than a week, maybe next Sunday.
See, they are telling, I knew the string word will come.
Yes, it's the most promising theory right now.
Because see, the electron is not imagined, we cannot imagine it like a ball, okay? Because then the quantum state, mass, changing this, the spinor.
See,
physical
why? See, I'm giving you one very simple explanation, very not quantum mechanics, not mathematical, but in a physical way. Why you should rely on a string-like analysis, not complete a string theory. See this. In nature, we notice that a smaller substance makes some bigger substance. Okay? If something is big, there must be something small inside it. Means by combining a smaller substance, you can make a bigger substance. You break a substance, you can get smaller parts to it. This story is unending. Like breaking molecules, you get atom. Breaking atom, you get electrons, nucleus. Inside nucleus, you get protons, neutrons. Inside proton and neutrons, you get quarks. The story is unending. So this will be not explanation. Why string theory gives us a feeling that I will be the game changer. See here. Remember, superposition of waves. In a classical view, I'm not describing quantum mechanics here. This is a classical wave. If you have a wave with exactly the same phase and amplitude, what happened? The resultant wave will be bigger than this. In both this. You'll notice that resultant wave is bigger than this. You'll notice the resultant wave is bigger than, means two smaller things combine and make a bigger thing. Now inverse of it. If two waves will go like this, what will be the result? The resultant is nothing. Means two bigger things combine and make a smaller thing, as small you think. And here,
nothing is zero.
A smaller world means micro world, worlds of atoms, molecules, electrons, and subatomic particles is easily explained by wave pattern than particle pattern. And in wave pattern, whenever you analyze wave pattern, you get a dancing string-like structure. And so, a string theory might be the most promising theory. Not exactly correct, not everything is accurate, everything has error, but it is quite better than other.
It looks much satisfactory than.
And it has more promising concepts inside it. And it's in the part of evolution and saturation also.
This channel, the Quantum Mathematics 777, they have built this slide completely.
Yes, thanks for the watching and thanks for your support. And keep asking your questions, and whatever be possible answer by me, I will give you.
We should make 2 days to fix. 1 day for the quantum analysis and 1 day for the relativistic analysis.
Yes.
I were supposed to come live today with my relativistic topics, but I haven't came. You came instead of me.
Okay, so in next slide, I will explain bigger than this the how electron, how this matter wave gives a mass, from where it has mass, and how it's interact with the electron field. And these are my works. You can get deflection from the proven theory. These are my works. Okay, thanks for the watching, and thanks for being in the live for
Yes.
since beginning to end. Thanks.
Many thanks to you.
Yes.
Edward retained breakthrough prize plus field medals. The listen to the per string theory here. Yeah, it's possible.
Yeah, these are quite exactly the means the deep analysis, the deep analysis or deep research hasn't any straight path. You can know this destination and reach there. You have to struggle. You have to make your own way. See, if we believe on the previous works only, you can never design a new path. So it's like a jungle where nothing is given, nothing is definite. You have to struggle, you have to clean everything, bushes, remove, and make your path to destination. Maybe sometimes you lead to a wrong goal, and sometimes you do. But your effort will be valued.
Yeah,
Understood?
they have suggested a book probably. Breakthrough prize plus field medal, the legend, superstring, meta theory. I think the M is capital.
Yeah. These are books, and mostly see in quantum mechanics, maybe the main goal is to reduce its certainty. It's
That's
uncertain.
why we have taken it as a string.
Yes.
Nobody have seen the electron there. It's really like
Now,
a string.
I'm asking a question to you that electron exists everywhere according to the, what does it mean? What is the physical significance? Is it outside atom again once and inside atom at the same time? So we have to work for this. And for these works, we have to think more and more. Sometimes we have to go deflection from the main book theory or book concept. We have to think by ourselves also. And read the great works of the great scientists.
The superstring theory, we'll try to read it. And will you go more on live?
Yes, no, that's end right? Thanks for the watching.
They are thanking us that you gave a very exciting question. Why half a spin? Thanks for your explanation, sir.
Thanks for you. Oh, I'm just your friend now. We are also in the same age.
We
Just
should
sharing
not
our
tell
knowledge.
we should not tell ourselves, sir or ma'am, I have seen your videos too, your mathematical explanations are quite very clearly written, told in the video. I have seen your videos.
Okay.
Thank you so much for being in the live and watching it. We'll again come live the next Sunday, and the topic will be something from relativity or quantum mechanics. Whatever is complete, we'll come live on it. My
Okay.
analysis is not complete yet.
Okay, thanks for watching.
Thank you so much. We are going to disconnect the live now.
Yes, end it.
In the string, wait. And
How long?